Hello everybody, and today we'll be doing Gatekeeper on TryHackMe. And this is an awesome room that requires you to write out your own buffer overflow script, so we can actually just do that. So why don't we first just start pinging this machine to make sure it's up, and it is up. And why don't we use threaded 3000? I'm not sure if that works. Yeah. And we can just do python 3 threaded 3000.py. The tool will be in the description below. And we just start that off. It's already finding SMB. I guess we can check that out even while it's running, but we'll just let this run out and see what it shows. Okay, and we can see that it is done. The port scan's done. And we just type in 1 and that'll start the nmap on it. So it'll automatically run nmap for us. Okay, and we can see that the nmap scan is done, and we can just take a look at it. Alright, so we do see SMB. We can see it's a Windows machine. It might be a web server. You also see this Elite, not sure what that is, on port 31337. We can also see Microsoft RPC. Okay, so that's great. Why don't we check out that SMB first? So SMB client -l. Let me just grab the IP address, which we can just do from TryHackMe. Okay. And we can see 4 shares: admin, C, IPC, and users. When we check out that users, so we can get rid of this -l, and we can just put in users. Alright, now we're here. We can ls, we can see share, so why don't we go and share gatekeeper.exe, so we can mget that, and just like that. Okay, now we can just move that into our directory gatekeeper into walkthrough. Okay, so now it is a .exe, so we can't run it on Linux. So why don't we put that onto our Windows machine, which you can have your own virtual machine for it, or you can just use your Windows that you're already using. So why don't we go into that walkthrough directory, and to download it onto our Windows machine, we can just start up a Python web server, and we can just certutil. So why don't we just minimize this, and we can come over here, and why don't we just go into the command prompt. First, you got to make sure your antivirus is off. Your Windows Defender and your antiviruses are off. Mine's already off because I was doing this room earlier. And you can probably create your own folder for it. I'm just gonna cd into Gatekeeper. I think that's what I called it. It's in my downloads folder, and then it's in Gatekeeper. Okay, so you can see nothing's in here. Why don't we just start doing that? You can do certutil url cache -f, and now we need to grab our IP address. You probably want to grab your eth0 IP address, not your ton0. So we can just do that. http:// you can paste that in there on port 80, and it was called gatekeeper.exe, and we'll just call it gatekeeper.exe. Let's see certutil completed successfully. You can see Gatekeeper right over here. Okay, so why don't we open up Gatekeeper? We can just do that. Gatekeeper listening for connections. Alright, so why don't we netcat to that port? We can just grab this, the IP address, netcat-v for verbose. We can place the IP address in here, and we'll also need to get the port number, which was 31337. So we're just connecting to this IP address on this port right now. We'll see what shows up. And if we come back over here, we can see nothing happened. Let's just type in test. It says hello test, so it's actually responding with something. Nothing's really showing up over there. We can try to type in something like hello, and it seems to be just repeating this message, hello, and whatever you type with 3 exclamation marks. So alright guys, I made a mistake over there. Sorry, you're not supposed to connect to this one. You're supposed to connect to your own IP address. So why don't we just exit out of there? No wonder we weren't getting anything. So you're just gonna need to close out of this for a second. Open up command prompt. You're gonna need to do ipconfig, and we'll need to grab your own IP address of your machine, which is this one if you're on Ethernet. You can just grab that. Oops. And you can just go back over here, netcat to that on port 31337. Okay, that did not work. Try that again. Netcat. Let's see if we have the right IP address. Should be the right one. This one right here. Netcat on 31337. Unknown host. Not sure why that's happening. Shouldn't be this one, should be this one. Is Gatekeeper not open right now? Oh, it's because Gatekeeper is not open, no wonder. Alright, sorry for that, guys. Messed it up so many times in this video. And we're gonna do port 31337. There we go, now it's working. If we do test, as you can see, it says hello test. Over here, bytes received 5, bytes sent 14, and you can see we typed in test. So yeah, why don't we see if we can put in a lot of characters and see what happens then. So we can do print. We can just type in Python here and it'll put us into this Python thing. And just print a times, we can just do 1000. Okay, and now we can also start up Immunity Debugger. And now if you don't have that, you guys can download it. I'll probably leave a link in the description if I remember. But yeah, so we can just click File over here, attach. You can see where's Gatekeeper is right over here, and just click attach. And something should pop up. Come on. Yes, and it's done. Alright, so now you want to start it by just clicking this button over here. You can see it's running down here. So why don't we put in a ridiculous amount of A's. So we can just zoom in over here, grab these A's. And why don't we come over here, we can netcat back to that. A ridiculous amount of A's. And you can see we don't actually get a response. If we look over here, we can see nothing shows up. Alright. So you can see that I actually crashed the program. So that's nice. Now we just have to find out where it's actually crashing. So why don't we restart this Gatekeeper. We can also start Immunity Debugger again. Attach. And we can start up Gatekeeper wherever that is. Here it is. We'll just wait for that to load up. Come on. Okay. You can see it's running. It's waiting, listening for a connection. And we can just do netcat to that, and we can just do maybe 100 A's. Let's see where it's crashing. Let's just do that over again. Print A times 100, so that's 100 A's. You just grab this. Okay, you can see that actually worked. It didn't crash anything. Everything's fine. Let's see if we can do print A times 200. We can just find out where it's actually crashing. We could write like a script to do this by itself, but let's just see what happens. Nothing's showing up. Okay, so that means it crashed. Send failed, and we can see Immunity Debugger is lighting up over here. You see 414141. Okay, so that's pretty much A's. That means it's a bunch of A's. So it worked. We overwrote the EIP. And if you guys don't know what this is and what I'm talking about, you guys can check out the Cyber Mentors Buffer Overflow Made Easy, or you can check out his practical ethical hacking course on Udemy, and that's really helpful. So yeah. So we overwrote the EIP, but we need to find out where we overwrote the EIP. So there's actually like a Metasploit module that we can use that creates a pattern, and it can do this. So why don't we just start this up? We're gonna just do Gatekeeper again. Also start Immunity Debugger again. We'll just attach this to Gatekeeper. We'll let that run. So the Metasploit, we can just do user. Oh, okay. It just exited me out. Okay, so it's ready. So we can just do user, share, Metasploit framework. We can do tools, exploit pattern, create.ruby. Okay, Now we just do -L, and the amount of bytes where it crashed. So we crashed it at 200 bytes. And that should give this random string of characters that we can just copy. And why don't we come back over here, clear, and we can netcat back over here. We'll start up immunity debugger. You can see it's paused right now. We'll start it up. Right, and now we can type that in there. You see it crashed it. Now we come back to immunity debugger, and you see we have this EIP value over here, 396.54138. We can just copy that, and we can come back over here, and we use another Metasploit module. We can do user share Metasploit framework tools exploit pattern offset. We need to find the offset, which is where it crashes. So we can do the crash at 200 bytes, and then -Q for the EIP value, which is what we grabbed from over here. I am recording, that's great. Okay, and now we can just type that in. You can see we found an exact match at 146. So it crashes at 146 bytes. So it's awesome. And now we can try to see if we actually overwrite the EIP, right? How do we do that? Well, earlier you saw 414141, right? That's a bunch of A's, like we said. So why don't we see if we can overwrite the EIP with just B's? Okay, so we can create a script for this. In my walkthrough directory, we can just nano bof buffer overflow.py. And why don't we just put in our shebang here? Just let them know there's a Python script. We need to import sys and import socket. Now, I do recommend you watch some sort of Python tutorial first if you have no idea what this is, because I'm not that good. I'm not that good with buffer overflows too, so don't expect a perfect explanation. So now that we imported sys and import socket, why don't we create a buffer variable? So this buffer will store a certain value. Now we'll just do a bunch of A's, right? And we put this B here for bytes, so we're changing this into bytes. So and we can do times 146, right? Because we got 146 from that from our Metasploit tool. We found the offset, and that's 146. We'll do plus in bytes again, and we'll do B times 4. So why are we doing B times 4, right? Because the EIP is 4 bytes long, so we'll just do B times 4. And what should happen in immunity debugger is we can see for the EIP it'll be 42424242, right? Because that's for B, 4242 is B. So why don't we create that buffer variable? And what else do we have to do? We create that buffer variable, but how do we send it to them, right? We need to connect. Okay, so what do? We use netcat to connect, right? We can have a try. So it'll try this, and if that doesn't work, it'll do something else. So we'll do s equals to socket.socket in parentheses socket.af underscore inet comma socket.sockstream. So what does this mean? Socket.afinet is pretty much your IP address, and then socket.sockstream is the port. Okay, we're sending out to S. So what do we need to do now? We need to connect to it, right? We'll just do s.connect. We got S over here, right? And now we need to set something inside. What do we need to set? We need to set the IP address, right? And the port. So the IP address, we need to set that to the our Windows IP address. And I think I remember it, 192.168.0.110. And then you'll need to set the port, which is 31337. Okay. So now that we connected to it, what do we need to do? We need to send them something, right? We need to send them the A's and the B's. So how do we do that? We'll just do s.send. So we'll send it to this IP address on that port. We'll just add that buffer variable because we already set the variable, right? It's 146 A's and 4 B's. So we'll just do buffer plus in bytes /r/n /r/n. And what this is called a carriage return, and it's pretty much equivalent to pressing enter on Windows. So okay. Now we'll just do s.close. We'll just close out of that, and we'll just do except over here because we put in try statement, which means try this, and if this doesn't work, I'll do something down here. So we can just do print error. Error. Then we'll just do sys.exit. So close out of it. Okay, so that's nice. And we'll see if we started up our gatekeeper and everything. We'll restart this gatekeeper, and we'll also start up immunity debugger. We'll do attach gatekeeper attach. Okay, now let's start it up. It's running. Now let's run our script. So we'll do python bof.py. You can see something went wrong. Invalid syntax. Okay, what did I do wrong? Has to connect. Oh, I forgot to put it in quotes. So in your IP address over here, you want to put this into quotes, just like that. Let's rerun it, and you can see it executed. Over here, you can see 42424242. So that means we overwrote the IP with the B's, right? So that worked. So what do we do now? We need to find bad characters. So when creating a payload, we don't want to use a bad character, otherwise it'll mess up and it'll fail. So how do we do that? We'll need to first we need to get a list of bad characters, and we can just Google that. So we'll just Google buffer overflow, I don't know, bad characters list. Okay, so bad characters list buffer overflow. You can see this one, bulb security. Let that load. Okay, see we have a list of bad characters. We'll just copy this, come back over here. Why don't we just nano bof.py. We'll just create a bad characters variable. So we'll just do this over here. We'll just paste it in. We'll turn all these into bytes. So we'll just put b. Oops, b. Okay, so now that works, and we need to also send this with s.send, right? We need to send it along with our A's and B's. We also need to send the bad characters over. So we'll just do plus bad chars plus, and we'll do the carriage return, and that should be it. So why don't we restart our immunity debugger and everything. We'll just do gatekeeper. We'll also do the immunity debugger. Okay, now we'll do attach. Just press G, and we'll do attach. And okay, it's paused. So we'll just press run. Now we'll come back down here. Now we'll run our script again. Python bof.py. See it executed successfully. Crash the program. 42 is again. So to find the bad characters, what we need to do is come over here to this ESP, right? Right click it and then click follow and dump. Okay, you can see it's right here. It starts over here. 0, 1, 0, 2, 3, 4, 5, 6, 7. Now I understand it's really small. I'm pretty sure there's a way to make it bigger. Text. I'm not sure how. Yeah, it's really small, but you'll pretty much want to check through all these characters and make sure nothing's wrong in there. So by default, the null byte x00, that will always be a bad character. So just remember that when we're making our payload. So you can just check through all these individually to see if anything's wrong. So you see 0, 1, 0, 2, 3, 4, 5, 6, 7, 8, 9. And you see 0, 0. There should be 0A, so I'm not sure if that's a bad character or not. But it's okay, we'll just add that to our bad characters list just in case. And we can see B, C, D, E, F, 10, 11, 12, 13, 14, and it'll just keep going on and on. You can check through all of these, but I already know because I already did it. So yeah, so now that's fine. So now what do we need to do? Now that we found the bad characters, what we need to do is find the right module to attack. So we'll do that with Mona modules, and I'll leave the link to that, the GitHub, in the description below. Also, you guys should watch Buffer Overflows Made Easy by Cyber Mentor, or his Practical Ethical Hacking course. He goes over this stuff way better than I ever can. So why don't we do that? We'll restart Immunity Debugger. We'll start Gatekeeper. We'll start up Immunity Debugger. But we can check to find out what module we should attack. So why don't we attach this to Gatekeeper, and once you install it, you'll be able to run from Immunity Debugger. So we'll just let that start up. Okay, and we'll just do down here, we can just do exclamation mark Mona modules. Right. Okay. So now you get the module information. You got to find out which module you want to attack, right? It's best to pick one that's false, like everything here, false, false, false all across. We don't actually see that, but this one's as close as we can get because everything's false here except for this one. and it's actually gatekeeper.exe. So we'll attack gatekeeper.exe. So what you want to do now is you want to find the jump ESP. You want to find the return address pretty much. So the way you do that, again, please watch Buffer Overflows Made Easy, because they'll explain it way better than I can. So we'll do find-s, we'll do xff xe4. It's pretty much ffE4, which is the jump ESP. Do -m for the module and gatekeeper.exe. You can see right here the results. You see it right over here. Let's see. You can see xFE4, and you can over here you can see the name, the module name. So why don't we just copy that down? So it's 0x080.414C3. Just copy that. We'll come back over here. We'll nano our buffer overflow, and we'll also need to delete this bad characters. I'm not sure how to do that from nano, so I'll just use gedit to do that. So I can select all of this and delete it all at once. Just delete that. Save that. Okay, now we'll nano buffer overflow again. Alright, so now what do we need to do? We need to attack that certain module. So over here, we can just type in something. We'll just comment it out because we have to change it, right? Because we need to write this backwards pretty much. So how do we write this backwards? So first, why don't we get rid of these B's over here? I don't think we'll need that. So plus, and again, we need to do some bytes. So how do we write it backwards? We'll need to do a \x c3, right? 2 characters, and then that, and we'll do \. We'll need to do x again, 14 \x04 \x08. Okay, so that's how we write it backwards. So now what do we need to do? Now that we've found the right module to attack, what we need to do now is actually try to exploit this machine, right? So first we'll need to add something called a no-op, which the cyber mentor explains is kind of like padding. So we can just do that with plus b for bytes, and we'll just do x90 times 32. Okay, and we'll also, but now what do we need to do is we need to encode shellcode, right? Shellcode. So how do we do that? We need to use MSF Venom, you know? So I'm gonna come back over here to pentest.ws. It'll make things a lot easier for us. Pentest.ws, and we'll just come over here to Venom Builder. If this will ever load. This is really slow. Come on, load up for me. Okay, now I'll come over here to Venom Builder. And I already set this up already, so you'll probably see it, but we'll do Windows shell /reverse TCP. We'll set the L host to our IP address, our TryHack. Well, actually no, we'll need to set it to our ETH0 address, because first we have to attack our machine. We're attacking our Windows machine. We're not attacking Gatekeeper yet. Let's hope it's not running out of time. We'll just add an hour. We'll set that to an ETH0 address. We can just set it to 6969. It's the L port. Bad characters. We went over this. The null byte will always be a bad character. I didn't see 0A in there, so I'm not sure if that's a bad character or not, but I'll just put it in. So format, we'll just do Python. Out file, we don't want to out it to any file unless you want to. I don't see the point in that. So now we'll just copy this command. Come over here. We'll let that MSF Venom run. We'll also do plus, and we'll wait for MSF Venom to complete, and it completed. Okay, and you can see it's turning it into bytes by itself already. So we can just copy all this. Come back over here to our script. Let's paste this in. Now, this is already set up for us. You can just copy and paste it directly, because buff, it's setting it to nothing at first and it's adding to it. Plus equals means whatever buff is right now, add this to buff, right? So it's putting it all in for us. So we can just come back over here and we'll just plus buff, right? We'll plus buff, which is the shellcode. Okay, so everything should be completed for us, except for the bad characters. Yeah, we don't need that in here. So we'll just remove that. So we'll just include the buffer, and it will include a carriage return, and that should be good for us. This should give us a shell, so let's just make sure it's running properly. Yes, it's running. Python bof.py. Oh shoot, we did not set up a listener, so that's probably why it failed. Okay, we'll close out of this gatekeeper. We'll start up immunity debugger. So I'll just actually start up MSF console, clear MSF console. I'm not sure why immunity debugger looks like that. Immunity debugger. Okay, that is weird. Why does it look like this? Whatever. Yeah, whatever. We'll just attach it to gatekeeper anyways. And we'll come over here. We'll just use multi-handler. We're done with the mini debugger anyways. Oh, okay. Just use multi-handler. We'll set our payload to Windows shell reverse TCP. We'll set our L host to 192.168.0.106, which is our ETH0 address on our Kali machine. So our L port to 6969. We'll start running that, and we can see that our yeah, it's up. Gatekeeper's up. So we'll just start that up. We can just do Python bof.py. That should give us a shell. Let's give us a shell. Let's just check our script again, see what we did wrong. I think should be right. I'm not sure what we did wrong. C3 14 0408. So that's right. Connecting correctly. So what did we do wrong? Did we do our... Well, let's try this again. Did it even crash? Not sure if it even crashed. I think it did. Let's start gatekeeper again. Do this one more time. Okay, yeah, and we got a command shell. I don't know what happened the first time. Okay, so we do who am I. You should see PC1, which is my Windows. So it worked. Everything worked. So what do we need to do now? We need to actually attack the actual TryHackMe Gatekeeper, right? So why don't we do that? We can just exit out of this. We can come back. So we can't just use the same script, okay? We need to change a couple of things. We need to change our payload to our L host. So why don't we just do ifconfig, we'll grab our TryHackMe IP address, and we'll just set that up over here. We'll do 9696. And we'll just copy this and paste that in. And we'll need to edit our script. So nano bof.py. So what do we need to fix? We need to change s.connect. We need to connect to the actual TryHackMe machine. So why don't we come back over here and grab the IP address, paste that in there, and everything should be good to go. And we also need to change this. So we'll just copy this, gedit, we'll delete all this, paste this in, we'll save it. Okay, and it's done. Alright, so now why don't we start up a listener? Where is our... Okay, show options, set L host to be what, ton0. Then we changed our L port to be 9696. Clear, run. And why don't we just run command shell 2 opened. Yes, and we got a shell. Let's just do who am I. Oops, what did we do there? Who am I? We are not in T-authority system. Oh man, you know, I was disappointed at this when I first did the machine. I went through all that work and I still wasn't system. But there is privexec here, so that's annoying. If we just do dir, you can see your user.txt is here. So why don't we upload? Well, first let's just do whoami/priv. Okay, you see we don't really have anything here. Why don't we upload winPEAS? Okay, so we just clear out here. It's in the opt folder, pyweb. So we'll just do. So I don't want to put it here. I'll put it in pictures. Nothing's here. Okay, cert util URL cache -f http:// I need our IP address. So why don't we just do config, copy that, come back over here, port 80 winPEAS.exe, winPEAS.exe. We'll see if that works. Okay, and now it's completed. We'll just do dir winPEAS.exe. So why don't we run winPEAS.exe now? Yeah, and we see it's not starting up, right? It's not working. And I can tell you that this is on purpose, so I'll see if I can background that. Yeah, I don't think winPEAS was supposed to be able to run. I wasn't able to get to work on the first time around. Let's see if I can go back into that session. Yeah, it's messed up. And it's closed. Okay, we need to re-exploit it. Why don't we run this again? Well, Python, buffer overflow. I got a command shell. Okay, so why don't we background this? And first, let's upgrade it to interpreter just so it's easy to work with. We can just do shell to interpreter. It usually doesn't work right away. I'm not sure, it's still slow sometimes. Set lhost to be ton0, set session to be 3, run. And this will pretty much upgrade our shell to a interpreter shell. Okay, yeah, and that didn't work. I'm not sure why. You can see it's still running here. I don't know, usually you have to wait a while, and I don't know, it just comes back with something. But it's fine, we don't really need it right now. But why don't we do search post Windows. We'll just do enum applications. We'll just 0 show options, and this will enumerate the applications that's on the machine. So why don't we set our session to what, 3, 4? Forgot. It's 3, I believe. 3. And well, let's just run this. Really, session may not be compatible. Come on. Background. CS sessions. Okay, I'm not sure why shell to interpreter didn't work. But we can upgrade it a different way. Why don't we just use MSF Venom again? We'll just do 1, 2, 3, 4. Same IP address. We'll change this to interpreter. I'm not sure if this will work. Bad characters out. Format. What is this? .exe. Out file to be interpreter. We'll just do shell.exe. We'll just copy this. Yeah, we'll just kill all jobs. Oops. Yeah, that worked. Let me go back over here and kill this job. Clear. And it worked. Okay, we'll just move the shell.exe to walkthrough folder. See walkthrough pyweb. And we'll just go back to the sessions. .i3. Okay, and we'll cd cd pictures. We'll cert util this over cert util. URL cache -f. The IP address again because I keep forgetting it. I never remember the IP address for anything other than CyberSec Labs because they made it easy to remember. Oops, can't use your arrows. Port 80. We'll grab over shell.exe and we'll call it shell.exe. Come on. Okay, and it's completed. Okay, well, we're gonna background this session. We use multi-handler, show options, set out port to be 1234, and set payload to be Windows, interpreter, reverse TCP. Run -j as a job, so it's running in the background. We'll do sessions-i3, dir, we'll do shell.exe. And we got a interpreter session open. So why don't we do sessions-i4. The background is first, sessions-i4, and we're interpreter, and we can just do get UID now and we can run interpreter commands. So when we run post windows gather, post windows gather enum applications. Now it's enumerating applications installed on Gatekeeper. Alright, and we actually got something back. Alright, what's most interesting right now would be Firefox. So we can try to enumerate we can try to find out what the credentials that are stored on Firefox is. And we can just do that with another Metasploit module. We can just do post multi gather Firefox creds. So now it's grabbing its credentials. We'll just let that run. Alright, and it's done. It downloaded all that stuff from us. So now we actually need to decrypt this, all these files. So why don't we come back over here? I have a lot of terminals open. Just cancel this one out, delete it. Okay, and I wonder where it downloaded to. If I download it to my, oh no, where is it? Where did it download to? Where did I start Metasploit at? My gosh. I started Metasploit somewhere. So it should be in here. Where is it saved at? Is it here? Where is it? Oh, it's .ms4, so it's here. Okay. We'll have to do else.la for it. So we can just move .ms4, move that. First, I want to rename it first. I'll rename it to Firefox, just so we can actually see it. And it's right there, Firefox. We can move Firefox into our walkthrough directory. CD walkthrough. Let's see, Firefox ls. See, loot. We'll go into loot. Okay. So now we need to decrypt this. We can. I think we can just search up Firefox Decrypt. You can see it's right here. I'll leave a link to it in the description too. Yeah, should be this one. Is this the one? Yes, it is. So you can just git clone this. I already have it, but yeah. So now we need to rename all this to these names. So why don't we just rename this? We can just copy this, right? And we can just rename this to, what is it? Like that. We need to do this for every single one of these files. So we did this one. Now we need to do this one. And like that. Oops. Okay. Now this one. We need to rename that to this. And now with the last one, just copy this, come back over here, plugins. Okay, now that we have all these renamed, we can come back over here to cd/opt, and it's in my Firefox Decrypt ls, and now it's Firefox Decrypt. So we just do Python Firefox Decrypt.py. But I'm pretty sure we just include the directory to it, so we'll just do it's our home directory, and it's in our walkthrough, it's in the Firefox, and it's in loot. Enter, and you can see we got some credentials. Okay, username mayor, the person who made this room, and now we have the password. So how do we log in, right? We saw SMB earlier, right? We saw SMB and some writable shares. So why can't we use psexec, right? So let's locate psexec.py. It's right over here. And we'll just do python psexec.py. I forgot how to use this. Oh boy. I think we need these mayor, I think it was, colon, password at the IP address. I think that's how you use it. Yes, it is. Okay, great. And we should be able to log in. Found writable shares on admin. So that's on SMB, and I found the writable share and uploaded that file. And then we just do who am I? We're NC authority system. That's awesome. And cd/users, and there's no admin. There's no admin folder. The root flag is in mayor, so it's actually in desktop. It's gonna go through all these. Come on, it's so slow. Okay, cd desktop. Now we can do cd desktop dir. You can see that's your root flag right over there. Alright guys, I hope you really enjoyed this video. I certainly enjoyed doing this room. Shout out to you, Mary. You're an amazing person and you made an amazing room. I really love doing it. The privilege escalation was, I was not expecting it when I first did it. So yeah, I hope you guys really enjoyed this video. I really enjoyed making this video. I think this is the first medium difficulty room I did on TryHackMe that I'm making a video on. So it's amazing. I really like this room. And it's actually a free room too. My subscription ended. I'm still able to do it. So this room is free, and seriously, you guys should really do it. It's a really fun room. And if you guys like this video, please leave a thumbs up and subscribe to me if you haven't. And yeah, I'll see you guys in the next video. Bye.